Right. Hi everyone, my name is Paul Roberts and I'm a developer at The Guardian, and I am going to talk to you tonight about macros in general, but specifically also about the way they're implemented and used in Scala. So macros are a subject which, to be honest, I always found sort of a little bit intimidating, and I think I'd kind of been putting off learning. But I recently worked on a couple of projects which kind of forced my hand a little bit, and I had to start investigating them. And so I'm hoping just to share with you just some of the things I picked up while doing that research. So I'm just going to talk a little bit about what are macros, macros in general is, and then we'll look specifically about how they work in Scala, how to use them. And then we'll look at some of the use cases of macros, what they can be used for, and then a little bit about the future of Scala Macros, because there are some changes coming up with that. So my intention is that, so obviously this is a relatively short talk, so it's just going to be sort of a high-level overview of Scala Macros, but my hope is that if you've not used macros before, you'll at least get an idea sort of what they can do and be able to make a better informed judgment whether they're useful for you to solve your problem. And also I was hoping they might help as well with debugging and that, because a lot of us sort of use macros sort of without necessarily realizing it, or not necessarily explicitly, because we're using a library that's got macros and stuff, and sometimes that can give us some really tricky error messages and stuff. So at least some basic knowledge I hope will be useful in maybe debugging some of those problems. So I started looking at macros, as I said, when I worked on a couple of projects. So I was using a library that was written by a colleague of mine, Phil Wills, and I definitely recommend the library. It's called Scala Macros, and what it's used for is automatically converting Scala types, well, automatically storing Scala types in a DynamoDB table and then bringing them back out again. But most of that tool is implemented as macros. So while I was working with that tool and doing sort of some fixes in that library and stuff, I had to sort of learn about macros, and while I was doing that I constantly had this quote running through the back of my mind, which I've slightly paraphrased here from Jamie Zawinski, but so you may have heard of this before, but so it really, so hopefully, sort of, as I said, I've paraphrased it, but hopefully you can see what I mean. And if you can't see what I mean, then maybe I'll just give you one of my favorite quotes that I've seen so far in some Scala documentation. So this is the description of a function from one of the macro APIs, and it says it migrates the expression into another mirror, jumping into a different universe if necessary. So I have no idea what that means, but it's like, I think it could be quoted directly out of Alice in Wonderland or something. So this is the kind of scenario that we're dealing with here. So let's start by saying what are macros, and then maybe that will kind of give us an idea of why they are so, why the API is so idiosyncratic, let's say. So it's superficially easy to answer the question, what are macros? So they're code that writes code. But what does that mean? Well, I'm sure we're all familiar with the idea of code as or programs are as something which manipulates data, and in order for them to do something that we're interested in, we need to make some kind of way of mapping that data into the real world. And so we create some kind of data model which allows us to map, as I said, map between things that go on in the real world and the data that the computer is able to handle. So if we're trying to create a program that can create programs, then I guess the first thing we need to do in order to implement a macro system is to create a data model that will allow us to represent code as data. So it's worth just taking a little sidestep here and just saying that what we're talking about in this context is not sort of like text replacement macros like you might get with like a hash define or something in a C preprocessor, where it just takes one piece of text and inserts it in another piece of text. So what we're talking about here is actual making logical decisions at the point where the macro is used to actually generate syntactic code, which can be just sort of spliced into the syntactic tree of the code that we're compiling. So it's slightly different, so it's and hopefully more flexible as well, but just to clarify that. So those kinds of syntactic macros that we're looking at here were popularized by languages like Lisp or Lisp type languages, because they have a couple of properties which make them particularly well suited to that sort of programming style. So for those of us, like I'm sure there's a lot of us that aren't totally familiar with Lisp, we can just see that one of the key elements that one of the key data structures that Lisp works with is the list. And not only that, but it also has the property that the code, when you actually write the code, you write it as a list. So that means you can use all of the extensive toolbox that Lisp has for manipulating lists. You can also apply that out of the box to code, because code is just lists. So I just have a really quick example here of just this is an expression in Lisp. It is a list, and the rule for evaluating Lisp is that the first element of the list defines a function and the rest of the elements define the arguments. So we're just applying some rather odd-looking tools for extracting out the end of the list and splicing on a different symbol into the beginning, and what the result of that is that we end up with a new expression which evaluates to a different answer. So what we've done is we've used the tools in the programming language to manipulate the code and change the way it executes. Now that kind of mechanism is pretty it is more than sufficient for expressing the simple syntax of Lisp. But of course, when we look at a language like Scala, well, it has a much richer syntax. And so we're going to probably need a much more complicated API for representing Scala code as data. And so this was introduced, so Scala provides this API as part of the reflection API, which was introduced in Scala 2.10. And what this does is, so this specific implementation actually makes available to us the syntax tree that the compiler is building up about your code, makes it available to us in the form of essentially of Scala types that we can just treat like case classes that we all know and love. So as we can see, there's an example of this where we're creating some we're sort of generating a syntactic tree of code by applying what I'm sure you would immediately recognize as using apply method from the companion object to generate these abstract data types. And so we can also see here as well as an example of why the syntax of Scala is much richer, because although this represents a very similar piece of code to the one we looked at from Lisp, this is a much more complicated syntax, because obviously the operators, as we know in Scala, are implemented as methods on an object. So we can't just call a function. We have to actually, or in this situation at least, we have to actually look up that function as a member of an object. So in this case, a literal integer. So that's just an example of, because that's just an example of the more sophisticated syntax that we have to represent with Scala. Now, obviously although this works and it's all well and good, it is quite quickly, you can imagine it will quite quickly become unwieldy as the expression that you're trying to represent gets more and more complicated. And also this is also looking quite a bit like the Lisp code that we were just trying to get away from, so there's quite a lot of brackets in there. So thankfully Scala provides us with an alternative, which is, of course, I had a couple of debates about how to pronounce this word, but I'm going with quasi quotes. But so anyway, so it's essentially, these quasi-quotes are very similar to string interpolation, which I'm sure we're all familiar with. And it gives us the advantage that we can actually write the expression very much as Scala code in the way that we would expect to see it if we were writing that code manually. But of course, it has a lot more power, because we can use the familiar $sign there to insert. So we can store bits of code that we want to use later into variables, and then we can splice them into a string, and the result is a syntactic expression similar to the one we just looked at on the previous slide. And this also is really powerful as well, because it includes pattern matching, which is really, it's quite amazing how simply it works, considering it's really complicated what it's doing. But you can just take a quasi quote and put in some variables in there, and it will pull out bits of the expression and assign them to those variables. So that can be really useful when you're trying to a much simpler way, at least, of manipulating existing code, and it's much more familiar to the sort of things that we're already used to doing with Scala. So all of this is great. This allows us to generate code, but of course course, it's only really one piece of the puzzle, because once we've generated this code, what do we actually do with it? Well, that's the next piece of the Scala Macros API, and that is something which allows us to insinuate this code that we've generated into the compile process as we're compiling our code. So the macro, as the macro is executed during compile time, it will generate this syntax tree that we've seen, and that will get spliced into the code that you're actually compiling, and that will become part of the project that you're building. And the macro is passed a context of the application point of where you're using the macro so that it can make decisions. So it will know what sort of arguments are being passed when the macro is being called, and maybe what types it's being used in that kind of thing in the context. So how we interface the macro into regular Scala code is an example of where we have different types of macros. So one of the most common ones is a def macro, which basically just simulates a function. So it looks like a function, it has a set number of arguments and a return type, and you can use it wherever you would otherwise call a different kind of function. You can even attach an implicit tag to it so that it can become like an implicit type class for you or something like that. So that's really handy. But of course it's different from a normal function because the body is custom generated by the macro expansion. So it's sort of dynamically generated at compile time. There's some other macro types for example, type providers and macro annotations, but they're all sort of varying acceptance and stability. So just to clarify, like the Scala macros are experimental, and they're sort of investigating at the moment what's useful, and so some things may go away or get developed further before they cease to be experimental. So that's one area where that really shows through. So let's just take a really quick look at defining a really simple macro to sort of put into practice some of what we've just looked at. So this is the macro definition. So this is telling us what our macro is how to use our macro, I guess. So the first thing to notice is that, as I said, it's experimental, so we have to do an import to enable them, otherwise this won't compile. So they're not enabled by default. And then all we're doing here is creating what you would recognize as a normal function with a return type and an argument. But instead of having a function body, it just has a reference to a macro implementation that we'll define later on. So we'll see that on the next slide. So what we're trying to do here, just as in this example, is just do a sort of canonical logging example where we're only going to print this string out if logging is enabled, but that decision will be made at compile time, so it won't have any performance cost on the actual runtime code. So this is the implementation of the macro, which was being referenced in the previous slide. So as you can see, this is again really simple. So what we have here is another function. So this function will get executed at compile time. So this is where I say we get the context of where the macro is being used. So I'm not using it here, but we could use this to make decisions about what code we actually want to generate. And then the next set of arguments that this function receives is something which matches up with the arguments that we defined for the function itself that will actually get called. But obviously, at this point, we're not in runtime, we're in compile time. So the actual values of these expressions aren't available. So what gets passed in instead is the code that would create those that would create those values. And then we can decide what to do with them within the body of the function. So all this does is use the quasi-quotes, as we saw previously, to just generate a print statement. But only if the logging is enabled. If it isn't, then we end up with nothing, no code being generated. So it's quite useful, I think, to sort of see how that works, or to see what effect it has, because when we do the compilation with a simple program which uses that macro, and we put in the xprint typer option, then we can see at some point sort of an idea of the code that's being generated by the compiler. And we can see that when logging is not enabled, then we actually have no code at all in that method. Whereas when we enable logging by, in this case, just by enabling the system property at compile time, then the code that gets generated has that print statement in it. So obviously in this case it's really simple to determine whether logging is enabled, but that could do any kind of processing or anything in the function at compile time to decide whether to enable it or not. So that's kind of a whirlwind tour of Scala macros and how to use them. So I think it's one of those things where it's relatively simple to sort of get a grasp of what they're trying to do, but the problem is it seems to be quite a challenge to actually implement them, I think, in ways that sort of map to what we already know of, and some things like quasi-quotes and that really help to do that, but I think there's still some challenges there. But now that once we've actually worked out how to use them, what are they useful for, well, I guess there's one of the key use cases, I think, is reduction of boilerplate. So probably we all know or think that Scala is a lot better at, say, Java than at reducing boilerplate. But there is still situations where Scala can have a lot of boilerplate as well. For example, if you have sort of unrelated types for which we want to create type classes, maybe like JSON serialization or something, maybe if they're case classes which just have normal Scala types as fields, then maybe the actual code to do the JSON serialization is quite common across them, but because they're not related types, it can be difficult to do that generically. So that can be an example where macros can help. And also they can be used extensively for sort of language customization and DSLs and things. That's not something I've sort of explored personally, but that is sort of one of the ideas. But I think that in many ways, Scala macros are probably more useful to library writers that want to either do something really amazing with their library or at least help other people to use their library. So they're not, a lot of the sort of general day-to-day Scala program probably uses a lot of macros but doesn't necessarily create them. So it might be something that, unless you're a specialist in macros, you do not so often. And there are alternatives as well, so you can just generate the code as text and then compile it. So, and you might automate that with an SBT plugin. So I know we've got some more information about SBT plugins later on, but you can certainly create a custom SBT plugin to generate your code. And we've done that a couple of times where we were examining a situation and found out that we actually didn't need a lot of the benefits and therefore the problems that come with macros, because we weren't really making any decisions at the time that the code was being generated. It was pretty much just static, based on a model that didn't change. And so we didn't need to, we didn't necessarily need the benefits of macros. But if you do need that, if you do need to make logical decisions within the context of the place where the macro is being applied, then probably macros are the only way to solve your problem. So what's the future of Scala macros? So as I said, it was experimental, so it seems that a lot of the decisions that are being made, or sort of the key decision that's been made, I think, is that they will actually be removing the macro API from the Scala compiler. But that's not to say that it's been like deprecated or that or they're suggesting that it hasn't worked. But it's more because at the moment it is really built around the compiler's knowledge of your Scala code, and it's impossible to extract it from that. So it becomes completely dependent on the Scala compiler. But what they're trying to do is make a macro API which is independent of the Scala compiler, so it has an independent external library to represent the syntax tree of your code. An example of that is the Scala Meta project, which is a really interesting sort of tool that for creating Scala code, which is probably going to be the main sort of place where macros will be used in future versions of Scala. And it also means that you can have competing implementations of the API as well. If you don't like one, someone else might create one, or you might create one. That's an alternative. And it also means that you can hopefully sort of reuse some of that code for other things. So for example, the Scala Meta API has been reused to create a Scala source code reformatter, which is a really nice sort of use case for a tool that can create Scala code. So that kind of brings us up to what I said we were going to talk about. So we've just looked at macros and Scala and looked at a bit of the future. So I've put up some references in the slides which you can use if you download them later, but otherwise that's it.